I'm Limengkiat from group 22. Now I'm demonstrating for the part 1, lab 2. This one is the graph that they gave us, and the Q is the output that we have drawn. When the D is in the high, but the clock is at the low, there's nothing changed at the Q. When the D is high, the clock is high, going up, the Q will be affected and it will go to up. When the D is 1, the clock doesn't click, doesn't get high, there's nothing changed in the Q. When the D is low, the clock is become high, the Q will be the same with the D state. It will become low again. So this one can be seen in this experimental. Okay. When the D is light and the clock is light up, the output is light. When the D is closed, the clock is closed, the output is closed. So that's all for part 1.
Hello, I'm Patrick Kong. I'm going to explain that two part. We have constructed the circuit over here. So we want to prove that with the clock frequency of 500 kilohertz, we will get an output of X with 250 kilohertz. I will explain why. Because the rise of clock module will cause the rise and drop of the output. So which means that the one period of output requires 2 periods of the clock module, which makes the frequency of the output become half of the clock frequency. So it is shown at the oscilloscope. As you can see, the channel 1, which is the clock input, is 500 kilohertz, but the frequency of the output, which is at channel 2, is 250 kilohertz. That's all.
Now we are demonstrating for the lab 2 part 3. Okay. This is our lab data, and this one is the truth table of this part 3 lab, part 3, and this one is our diagram. Only the D0, you can see from the diagram, the D0 is connected to VCC so that the count always starts from 1. And when the count comes to 6, the NAND gate will return the 0, which this part will return the 0, so that the PE, which is pin 9, will disable the counting action and cause the data in the data input D0 to D1 to be loaded back into its original state, which is the 1 in these cases. So that this and this one is our experimentation data. Okay, so when we start from the counting, this one is 1, and we press the input, you count 2, 3, 4, 5, and when 6, the light will be off, because this one will return the 0 value. And yeah, that's all for part 3.
So this is part 4 and 5 together. So this is basically part 3, but instead of using the LED to count from 1 to 6, we use the die module. So this is the K-map of the combination of 4 possible light patterns to count from 1 to 6. So this is the results, and then we have simplified it into the truth table. So this is the truth table of pattern A, B, C, and D. So you can see A is Q0, B is Q1 and Q2, C is Q2 alone, and D is Q1 or Q2. And then this is the circuit design. Okay, so this is the circuit, the physical circuit of the part 5. So right now you can see the die pattern will start from 1, 2, 3, 4, 5, and 6. Yeah, so that's all.